Hi, my name is Shreyas Mhalsekar. So here there are three group members. First one is me, that is Shreyas Mhalsekar with a student ID of 250761112, and one is Siddharth, and another one is Phongsakorn War. So here basically this is our security services architecture design. As you can see, it includes VPCs like VPC links, Amazon API gateway, like many identity services, log and monitoring, security and compliances, as you can see. So basically here I'm going to share my screen. So yeah, so basically just a sec, yeah. So yeah, the first part is the network part. The first part of the network architecture is like the access, like the VPC in AWS. So basically, it's like I will start explaining the network setup of our architecture, our design center, like on a virtual private cloud or a VPC which isolates our application resource within a secure private network on AWS. This VPC is actually like the core of the network architecture, the network infrastructure, basically providing a controlled connectivity and segregation of components. So basically here you can, as you guys can see, the VPCs. So here is the VPC, which we have made, and down you can see the subnets as follows. So another part is the NLP, that is the network load balancer. So the thing is that basically when our network when a traffic enters through a network load balancer, which actually distributes incoming traffic across various sources. As you can see, there is a load balancer. So basically load balancer ensures higher availability by managing the endpoints, especially the API gateway. So basically, the load balancer is configured for the internet facing, allowing it to receive external requests, forwarding them to the correct services within the VPC. So as you can see, we have made our load balancers. As you can see, the availability zones. So there are two ports, like the as you can see, the listening and in the listeners and the rule section. So another one is, and then is the API gateway. So as you can see, basically, so we have created APIs. Just a second. So yeah, basically, yeah, we have created two types of APIs, the CUS API and the financial API. So as you can see, it uses two protocols. One is the HTTP, and the REST protocol. So basically, so we have created APIs for our application for functioning within our API gateway using an HTTP API to link with VPC links. So basically, VPC links are used to access private subnets, which are outside the internet or with other AWS services in a controlled manner. Basically, the API gateway gets divided into two main endpoints. You can say the API endpoint for general requests and the auth endpoint for authentication purposes only. So we have actually set up a VPC link to allow the API gateway to securely connect the backend services with the VPCs, maintaining a secure connection without actually needing to expose any private sources to the internet. And another part comes the multi-region setup, or like it's actually basically necessary for redundancy, basically for disaster recovery and business, and also for business continuation. So as I will go to S3, so the bucket is loading. So actually here we have made two backups. As you can see, one is the hot storage backup and another one is the cold storage backup. Here actually we can use the NAT gateway for internet access for services which need to connect to the internet while remaining in a actual private subnet. Region 2 holds backup instances of our main components such as the elastic cache and the financial database for redundancy and disaster recovery purposes. Another part comes the security. Just a sec. Yeah, these security leaks. Just a second. It's taking some time to load. as it's taking some time to load. Basically, security groups and subnet configuration. Subnets are like security groups. You remember the VCs, VPC link like which we created. So I'm not able to find the subnets. Just a second. Yeah, it was in the subnet configurations. Subnet, yeah. Yeah, perfect. So basically, these are the subnets, which basically you remember the VPC links we created. So here are the actual subnets. So finally, we employ security groups to manage access control, ensuring only authorized services can communicate. Public subnets are used for components like the load balancer and the API gateway, while private subnets are dedicated to the app servers and the databases. As you can see, like this segmentation adds layers of security to protect sensitive data, which actually it's actually necessary for every client. So another one, now we go to the WAF. So basically, these are the web ACLs. Like this is the web application, like it's like a web application firewall that we are using to manage the traffic flow, like in and out. So here we can see in the web ACL section. So yeah, there are the two ACLs. Basically, ACLs over here are to manage the incoming, that is the ingress for our network. Similarly, depending upon the requirement, we can create more ACLs to manage the traffic flow. So yeah, this was my part.
Okay, for my part, hello, my name is Phongsakorn Ardong. My student is 2511009H. For my part, I will discuss how we manage our database and other essential service. At the core of our data management, we have the financial database hosted on the RDS, Amazon RDS. This database store critical financial data, and it is located within the private subnet for security. And Shreyas said and the database setup include automated backup and point-in-time recovery to ensure the data integrity. And the first part, I will say about key management service as we use in our architecture. We use the KMS for the manage encryption key for data atlas and data in transit. KMS allow to encrypt sensitive data stored in the database, ensure it remains secure even if accessed outside of the application. As shown on my screen, we here the customer managed key here, and we using the alias name as I3KMS. Moreover, we use it as a multiple region as shown here. We use in the first region is located in Sydney, and another one is as shown here located in Singapore. And another service is RDS. The RDS, we create financial cluster of the financial database as shown on the screen, and show here we have two instance inside. The first one is the two of them are both of them are located in the same region, but in the different variables zone as shown on the screen. The first availability zone is 2B, and the second one is 2A as shown here. And moreover, we also create a backup every day for the security reason. And another one is we manually export is to the Amazon S3 by manually. And moreover, we, in case of support high-speed data asset, we use the elastic cache. Also on the financial database, we enable the latest OS cache as shown on the screen to indicate. For the next is the EC2. Sorry. Okay, in EC2, we have two applications. The first one is the application server, and the second one is the web server. For the first one, web server, we create a security group as shown on the screen. We have two inbound port. That the first one is the SNS port, and the second one is the HTTP port. And for the app server as shown on the screen, we create security group for inbound only Ethernet port for the in case of a configuration manually. And moreover, we also have the inbound port actual in the TT06, that is the MySQL port for uh, we integrate the app server with the financial database server also. Okay, for the next I will show some the demo that we integrate is completely. And the first one I will show you that we enable the key pair, that is the only one method we can access to our web and application EC2. As shown here, I will use this command to connect to the app financial app server. Yeah, we use the SSH key, right? And the second one, we connect the web. Yeah, actual screen, we prove that the key is working. And another one, as I said, the app server connect to the financial database, right? I will using command to prove that our database was connect. For the passwords of the financial database, we using the secret manager as shown on the screen to automatically store the database passwords. And we can retrieve it as shown on the screen. The username is and password is here. We copy this and show that here. Yeah, we connect to my SQL data completely. And another one, for the web server, we completely allow is form is actual on the screen. This is a mock-up service, not actual financial service. Okay, let's move to the security part.
Thank you, Rob. Hi everyone, my name is Siddharth Jha, student ID 250285003, and I'll be talking about the security and privacy measures that we have taken within our architecture. So please allow me to share my screen. Please let me know when you can see my screen. Okay, so let's start. First, let me just give you a recap of the financial architecture, financial system architecture that we have created over here. As you can see, for security purposes, we have done multiple things. One of which is we have a multi-regional backup that helps with redundancy when it comes to data redundancy, when it comes to disaster recovery and business continuity. At the same time, we have used private subnets and for our confidential databases, and we have not directly exposed it to the internet. And we have used multiple logging and monitoring and security and compliance services, which I'm going to show you in just a second, which we are using to ensure we can comply with international standards of security and compliance. So let's start with IAM Identity Center. We use IAM Identity Center to essentially manage our workforce in the organization. Over here, as you can see on this particular account, we have multiple user groups and multiple permission sets available. So we provision each user group with required permission set that would allow the particular group or any user within that group to access the AWS resources to a certain extent. We have workspace admin who will have full access. We have finance admin who will have billing access. So they'll be able to use resources such as cost and billing to ensure that we are not, to ensure that the budget is taken care of. And then we have workspace developer, which is where we use network administrator and power user access to ensure that they have full access to all the services to manage them, but at the same time they do not have access to delete or modify user groups or permission sets. Now, let's move on to IAM, which is slightly different. So in this scenario where a third-party application or another AWS service needs to automate a certain process, we'll be using IAM role. As you can see, there are multiple preset roles managed by AWS. You can create a role for yourself depending on what sort of entity type that you're working with and the use case. But essentially, IAM roles are great when one wants to automate certain processes but does not want to give access to GUI of the AWS console, but rather just have a CLI access and a limited role access. Now, the first service that we have used in logging and monitoring is CloudTrail. The good thing with CloudTrail is that it is a wonderful application because it gives you a very in-depth audit trail, or it helps you to create a very in-depth audit trail for all the services that are running on your AWS account. It also gives you the API logs, so you can use these logs. You can use all these logs to push them into a SIM, which is a security incident and event management system, and you can visualize these logs over there to ensure that you are able to monitor activity within your AWS account and within on your application at any given point in time. The second logging and monitoring application is CloudWatch, which is another monitoring resource which monitors the metrics of each and every services that are running within your account. So it will tell you any sort of anomaly or any sort of issues that might have come across in within your services. So it is more or less used to monitor the health of your services to ensure that your uptime is not affected. You can create custom dashboards. We try to create one custom org dashboard over here, but since we do not have much data over here, there isn't anything visible. But essentially, you can visualize all that information using custom dashboards. Now that we're done with logging and monitoring, let's move on to the security and compliance services. The first one over here is Inspector. We use Inspector for vulnerability and code management. Inspector essentially, analyzes three different services, primarily the ECR, the Lambdas, and the EC2. Since we have not created Lambdas, you might not see the repository of Lambda functions over here. But as you can see, we have created two EC2s, and it is right now scanning for, configuration or package vulnerabilities within that EC2. The first party code scan that Inspector does is only limited to Lambda. And if there were any Lambdas available and there were code inside it, it would be able to scan it for secure coding practices and related to OWASP top 10 or other benchmarks. Now, if you were to go by vulnerability or finding, let me show you how already, it has highlighted multiple critical and high vulnerabilities depending on, they're all package vulnerabilities because for EC2 and ECR, it mostly does package scanning. Now, moving forward for threat intelligence, we have used GuardDuty. GuardDuty is an excellent tool, especially because it uses very complex ML models and AI to ensure that it is able to highlight each and every finding that it might find across any services running in this account. So let's just say there is an eavesdropper or there is a threat actor who's trying to gain access to your environment through SSH or through a backdoor. GuardDuty is the first place where you'll see that finding come in, and you can also create alerts so that when GuardDuty finds something critical or high, it can directly send it to your Jira board or to any other application where you might be using for managing tickets. So for example, over here, you can see that there is a very low credential vulnerability that we have found, and it gives you very in-depth detail of which region, which account, which service is affected, how is it affected, and you can further investigate this using AWS Detective, because we are also using AWS Detective, which is essentially a service that we use to analyze any sort of interesting findings that we might have got through GuardDuty, and not just GuardDuty, but any other service for that matter, as long as it's a security finding. So we are using Detective for that post-incident response, or even during the incident response when you want to, understand a particular finding or vulnerability further. Now, it is very difficult on a production scale for anyone to constantly keep track of all the three services. So what we use to consolidate all this information is Security Hub. Security Hub is an excellent tool to manage two things. One is your compliance. So your compliance with international standards like the PCI DSS, NIST, AWS foundational practices. And what you'll see over here are different controls that one needs to comply with to ensure that you are, you are at the benchmark level. But at the same time, it also tells you any and all findings that might come from inspector, guard duty, or detective, or any other services. So as you can see over here, we already have a lot of findings. These are the same findings that you saw earlier in inspector, but over here is just it's just consolidated information, so it's just easier to manage. So Security Hub is essentially a one-stop solution for security and compliance. Now that we have talked about Security Hub, I would like to talk about, let me see if I'm missing something. Uh, Okay, yeah, I would like to talk about AWS Config. AWS Config is essentially used as a service to configure or to manage configurations of any network flow or any devices within your account. You can create rules to ensure that all these services, all the network traffic that is going through your account manage confines to these rules. As you can see, there are multiple rules that AWS provides you. You can also create custom rules. We have created certain rules over here which are specific to app sync login or specific to Security Hub issues. The rules can be services based or can be action based. Now that we have spoken about AWS config, yeah, I think we are good to end the we are good to conclude the project. So essentially what we've tried to do over here is use a mix of security services and logging and monitoring services to ensure that we have the exact idea of how our account is behaving, and if there is any sort of intrusion or anomaly detected, that we can take care of it right away. Thank you so much, and that's our project.